Hello everyone. So today we are going to discuss on the topic concept of real and apparent depth. So what this phenomenon of real and apparent depth also takes place due to the phenomenon of refraction. Due to the phenomenon of refraction, this occurs also due to the phenomenon of refraction. Okay. So students, this phenomenon of real and apparent depth also occurs due to the phenomenon of refraction. Okay. So if we see, suppose there is a glass, that means a water, it may be any can or a glass carrying water. It contains water. Suppose this is a glass, it contains water, and there is a coin over here. In this place there is a coin at the bottom of this glass. So a ray from this coin will directly move in this way, that is, it is moving in the normal way. That means if this is the normal, how is a normal drawn? Suppose this is the surface, so this is the normal, and this ray is also moving along the normal, so this ray will not suffer any refraction. Why? Because this ray is moving along the normal, so this ray will not suffer any refraction. But let us consider, suppose if we draw a line over here, suppose this is the line, this is the line over the, this is the line on the surface, if this is the surface, so this is the line on the surface. So let us consider another one ray in this way. This time this ray will suffer refraction. That means it will bend. This ray will bend. This ray will change its path. So let us see how does this occur. Suppose this ray has moved in this direction after refraction, because this is the denser medium and this is the rarer medium. So it will, if this is the rarer medium and this is the denser medium, this ray will move away from the normal. Why? Because this is the rarer medium, this is the normal, Suppose let us consider n dash, this, let us say this point to be o dash, and let us say this point to be n. So n dash, o dash, n is a normal. So this ray after striking the surface will move away from the normal because it is moving in the rarer medium. So that's why this will be the angle of refraction, and this will be the angle of incidence, and here also, since this ray is moving along the normal, this will be the angle of incidence, and this will be the angle of refraction, because it will not suffer any deviation in its path. This ray will not suffer any change in its path. That means it will move in the same path as it was moving in the denser medium. But in case of this ray, this will suffer a change in its path. So this will suffer a change in its path. So it has suffered a change in its path. So let us extend this change in path, that is the ray in the rarer medium. If we extend the ray in the rarer medium in the backward direction, that is if this is the ray in the rarer medium, if we extend this ray in the backward direction, so what will we get? We will get a ray somewhat like this. If we extend this ray in the backward direction, so this line will intersect this line at this point. This line will intersect this line. So let us say this point to be A, and let us say this point to be A dash. We are saying this point to be A dash, and this point we are saying it to be A. So now this is the angle of incidence, that is I. This is the angle of refraction, R. So if this is I, this angle will also be equal to I. Now If this is I, this is I, and if this is Y, because see, if these two are parallel lines, there is another one line which crosses these two line, in this way. If this is the angle I, this will also be equal to I, this will also be equal to I. On the other hand, if we see here, this is the angle of refraction small r, this is the angle of refraction small r. If this is r, this whole angle will also be equal to r, that is small r. Why? Because in this case it is like this. If this is r, this will also be equal to r. So if this is r, this will also be equal to r. So if this is r, this will also be equal to r. So if this is r, this angle will also be equal to r, this angle will also be equal to r. From this diagram, we can say, from this diagram, because here it was I, so this is I. So if this is r, this will also be equal to r, that is, if this is r, this will also be equal to r. So now if we say this medium to be 1 and denser medium to be 2, so in this case the ray is moving from denser to rarer medium. So here we can say, since this ray is moving from denser to rarer medium, the refractive index we can write it to be N12. The refractive index we can write it to be N12, which is equal to 1 by N21, which is equal to 1 by N21. N12 is equal to 1 by N21. So let us say N21 to be N. N21 we are considering N21 to be N. We are considering N21 to be N. So from Snell's law, what can we say? From Snell's law, we know that refractive index N is equal to sine I divided by sine R. So this is N. Refractive index N is equal to sine I divided by sine R. So here in this case, the refractive index is N12. Here in this diagram, the refractive index is N12. So N12 will be equal to sine I divided by sine R. So how can we write N12? N12 can be written as 1 by N21. N12 can be written as 1 by N21, which is equal to sine I divided by sine R, which is equal to sine I divided by sine R. This implies 1 by N is equal to sine I divided by sine R. This implies, because we have considered N21 to be N, so this implies 1 by N is equal to sine I divided by sine R. So what can we write for sine I? This is angle I, so we can write sine of angle. If we consider this point to be O, because we have considered this point to be O dash, so we are considering now this point to be O. So sine I, what is angle I? Angle I is this angle, that is this angle. So this angle can be written as OA, that is angle OA O dash divided by sine of R. What is angle R? Angle R was this angle. So this can be written as O A dash O dash, angle O A dash O dash, which is in turn equal to 1 by and which is equal to 1 by n, because refractive index was n12, which is equal to 1 by n21, and we have considered n21 to be n. So 1 by n is equal to sine of angle OA O dash divided by sine of angle OA dash O dash. So this implies 1 by n is equal to, now sine of angle OA O dash. So if we see in the triangle OO dash A, if we take sine of angle OA O dash in the triangle OO dash A, if we take sine of angle OA O dash, what will we get? Here this is the perpendicular in the triangle OO dash A. In the triangle OO dash A, OO dash is the perpendicular, OO dash is the perpendicular, and AO dash is the hypotenuse. AO dash is the hypotenuse, OO dash is the perpendicular. So sine of angle OAO dash will give you OO dash, that is the perpendicular divided by hypotenuse. Perpendicular divided by hypotenuse will give you this angle, that is sine of this angle. Sine of OAO dash, sine of OAO dash is what? Is perpendicular divided by hypotenuse. So in this case the perpendicular is OO dash. In this case the perpendicular is OO dash and the hypotenuse is AO dash. So this will be equal to, so 1 by n will be equal to, that is sine of angle OAO dash is equal to OO dash divided by OO dash divided by AO dash divided by AO dash. Then sine of angle OA dash O dash, sine of angle OA dash O dash, that is angle R, sine of angle R. So sine of angle R will give you what? Sine of angle R will give you OO dash divided by A dash O dash, because sine of any angle is what? Perpendicular divided by hypotenuse. So in this case perpendicular is for the triangle OO dash A dash. If we see for the triangle OO dash A dash, then sine of A dash, sine of angle R, sine of angle R will give you OO dash divided by A dash O dash, because this time OO dash is the perpendicular, the same is the perpendicular, but the hypotenuse for this triangle is A dash O dash. Hypotenuse for this triangle is A dash O dash. So we have written A dash O dash below and OO dash is above. So now this implies 1 by n is equal to A dash O dash divided by AO dash, A dash O dash divided by AO dash. This implies n is equal to AO dash divided by A dash O dash divided by A dash O dash. So if we take this reciprocal, that is if we take this above, so this will also go above, that means n will be equal to AO dash divided by A dash O dash. So if this O dash point nears O point, if this O dash point move to O point, if this O dash point tends to, if O dash point tends to O point, in that case we can write refractive index n is equal to AO if this O dash point move to O point. In that case O dash will overlap over O. In that case O dash will overlap over O. So n will be equal to AO divided by A dash O, AO divided by A dash O, AO divided by A dash O. But AO is nothing but real depth. AO is nothing but real depth, because this is the surface of this denser medium. This is the surface of this denser medium. From the surface to the bottom, this is the real depth, and this is the image of this object. This is here the image of this object appears to be at this point. The image of this object appears to be at this point. So this is the apparent depth. 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 So the real depth is this and the apparent depth is this. So the real depth we can write it to be AO and the apparent depth we can write it to be A dash O. So this is what we have written, N is equal to AO divided by A dash O. So AO we have called it. So AO we have said it to be real depth. That means N is equal to real depth divided by apparent depth. Real depth divided by apparent depth. So this was the concept of real and apparent depth due to the phenomenon of refraction. When an object is present at the denser medium, and the observer is in the, here is the observer. So the object is present in the denser medium. This denser medium is water. Here the rarer medium is air. So the object is present in the rarer medium and the observer is present in the rarer medium and the object is present in the denser medium. So this was the concept of real and apparent depth. So thank you, students.